we will study about some tricks about acids and base. Now we will study that how we will differentiate between strong acid and strong base, clear, or strong acid with weak acid, strong base with weak base. So there are some tricks about acids and base and their strength. So today we will study about some tricks which are involved in distinguishment of acid and base, or the strength of acid and base. The first one is charge, positive charge. You know, and you have already studied different types of concepts about acids and base. Clear? Positive charge. Positive charge means a species which have already lost some electrons. For example, calcium plus 2, clear, chromium plus 6. You are saying here that these species have lost some electron, so these are acids, clear. So the first one, species or ion having more positive charge will be more acidic, clear. So here you can see that chromium plus 6 is acidic than chromium plus 3, clear. So a species which have higher positive charge will be acidic than that species which have less positive charge, clear. Number 1. Number 2, electronic configuration. Electronic configuration. And second one, electron density. Electronic configuration and also electron density. So positive charge, a species having more positive charge will be acidic in nature than that species which have less positive charge. So this was the first trick, and you can solve such example here, clear. आगे चलते हैं. Resonance, you should know, resonance is actually distribution of charge in a structure, clear. So for example, here there is negative charge on the ring, clear, and here is also a negative charge on the ring, clear. So which one will be more, or for example this is also a choice, clear. So the question is that which of the following is more acidic, or which of the following is most basic. So now you can see here the resonance, about the resonance structure. A species having more resonance structure will be least basic in nature, clear. A species having more resonance structure, most canonical forms will be less basic in nature, clear. So here you can see the reason. What is the reason? The reason of the least basicity is that this negative charge, you can see here that this negative charge is not localized here, and the chance of attack of H plus ion on here is very less, clear. And you also know that the species which donate electron are basic in nature. So you can see here that this ring is actually electron withdrawing group. This ring is electron withdrawing group, and this ring is electron donating group. This ring is electron donating group. It means if a chain donate its electron toward negative charge, then what happen? The electron density of this negative charge will increase, and this negative charge will localized, and the reactivity of this negative charge will increase because charge density increases here. Again listen, here you can see these three structures, and now we concluding that this structure is least basic as compared to these two, because the acidity of the basicity of any species depends upon the charge density. So if a compound have most resonance structures, then there will be least electron density of this negative charge, and electron will be not localized at this position, so no one can attack on this negative charge. It means it cannot donate its electron to others. Clear? So in these three structures you can conclude that the negative charge of this structure are in resonance with the below given structure, while this negative charge and this negative charge are localized, and also this negative charge are also supported by this ring, is also supported by this ring, because this ring induct its electron toward negative, while this ring withdraw, this ring donate its electron toward negative, while this ring withdraw electron from this negative. So these two ring increases the electron density on oxygen. It means reactivity of the charge density of these the negative charge on oxygen increases. It means reactivity increases, localization of this negative charge increases. It means these two structures are more basic in nature as compared to that. Clear? So higher the resonance structure, higher the resonance structure of negative charge species, less will be its basicity, less will be its reactivity. Clear? So you have also noted a point. Clear? You have also noted a point. Clear? Note down in your register, in your own registered book. Clear? So this is for a for basicity. If I want to write it for acidity, so what will be its reality? For example, one structure is that clear, the other one is that for example that clear, and the other one is that clear. So the question is that which of the following is strong acid? Which of the following is strong acid? Our answer will be this one is strong acid. This one is strong acid. Why? Because if we remove the hydrogen from these, all of these, from these oxygens, clear, so we will write negative here. Clear? So you know that a strong acid have most stable conjugate base. Strong acid have most stable conjugate base, or the base of strong acid have low reactivity. Clear? So this is a base, this is a conjugate base of this acid, and this is a conjugate base of this acid, and this is a conjugate base of this acid. So this acid have very stable conjugate base. This acid have most stable conjugate base, and this conjugate base have low electron density. Charge are localized. Clear? So a higher resonance structures. Clear? It means this base is most stable. if the conjugate base of an acid is most stable, it means its acid is most strong. Clear? Okay. So again, hybridization also affect the electronegativity of a species. For example, you can see here this structure, one is that, second one is that, and third one is that. Clear? So there are hydrogens attached here, and there are also hydrogen. Clear? And there is also hydrogen. Clear? So what will happen? Clear? Another trick, if the carbon atom have sp hybridization, in sp hybridization S character is greater, about 50% character here of s orbital. So higher the characters of s orbital, most will be electronegativity. Clear? Most will be electronegativity. It means sp hybridization have more electronegativity as compared to sp2, which have more electronegativity than sp3. So a carbon atom having sp hybridization will have more s character. If the s character in any carbon atom is more, its electronegativity increases. If its electronegativity increase actually the acidity of a species. So you can see here sp hybridization is present, here sp2 hybridization is present, while here sp3 hybridization is present. The s character in this carbon is about 25%, which is less than this and which is less than this. So it means this is most acidic than this one, and this one is most acidic than this one. Or acetylene is acidic than ethylene, and ethylene is acidic than ethane. Clear? So if a carbon atom or if any a central atom have sp hybridization, then it will be most acidic than sp2 hybridization, and sp2 hybridization will be more acidic than sp hybridization. Clear? So next one, electronegativity. Electronegativity also affect the acidity in different ways. Clear? So I can write, if here you can see the electronegativity increases the acidity, while in some cases electronegativity decreases the acidity. Clear? For example, in hydride forms, for example in diatomic molecules, for example HF, HCl, HBr, HI. Clear? Here HI is acidic than HBr, which is acidic than, and which is acidic than HF. What is the reason of this acidity? Clear? So actually in a large compound, if electronegativity increases with respect to hybridization, acidity will be increases. But here you can see the electronegativity is not increases with respect to hybridization, but here the electronegativity is the nature of every element: iodine, bromine, and chlorine and fluorine. So you can see here the electronegativity of iodine is less than bromine, which is less than fluorine, which is less than. It means this bond is weaker. Hydrogen iodine bond is weaker than hydrogen bromine bond, which is weaker than HCl bond, and which is weaker than fluorine hydrogen bond. So the chance of breaking of bond of HF is weaker than HCl, which is weaker than HBr, which is weaker than HI. Clear? So the bond of HI will break easily as compared to HBr. Clear? So it means HI bond can easily be broken down, so it is acidic than HBr. The bond of HBr can easily be broken down as compared to HCl, and the bond of HCl can easily be broken down as compared to HF. It means here you can see in hybridization form, if the electronegativity is with respect to hybridization, increasing the electronegativity with respect to hybridization, acidity will increase. But here, if the electronegativity in diatomic compound molecule, there every element have its own electronegativity in such aspects. The bond strength is here is stronger than that, which is stronger than this bond, which is stronger than this bond. So stronger the bond, weaker will be acidity, because we cannot break the bond. If bond cannot be broken down, it means H plus ion cannot be released. If H plus ion cannot release, it means its acidity decreases. Clear? So another way you can also know that here the conjugate base of this species is I negative, conjugate base of this species is Br negative, and conjugate base of this species is Cl negative, and conjugate base of this species is F negative. Clear? It means stronger the acid, stronger acid will have more stable conjugate base. Clear? Stronger acid will have weak reactive conjugate base. Stronger acid will have most stable conjugate base, because you can see here the stronger acid will have most stable conjugate base, because here the base have large size, its charge density decreases, its reactivity decreases, because if charge density decreases, no one can attack on this negative charge. It means stronger the acid, stronger acid will have most stable conjugate base. This most stable conjugate base will have large size. Clear? And this large size will have low electron density. If any negative charge owner have low electron density, it means it have more stability. No one can attack on it. It means this negative charge cannot recombine to form acid again. Clear? Okay. Electronegative and size. We have already discussed this about the size. If the size increases, here you can see size increases here. This term is for conjugate base. If the size of the conjugate base increases, its charge density decreases. Because charge density depends upon the volume of the negative species. Clear? So if the size of the negative species increases, its charge density decreases. If charge density decreases, its reactivity decreases, because charge density is directly related to reactivity. It means if charge density decreases, reactivity decreases. If reactivity decreases, stability increases, because stability and reactivity are inversely proportional to each other. Clear? And you can also see here from right to left, size increases, stability increases, because charge density decreases. Reactivity decreases, stability increases. Clear? Okay. This term for negative conjugate base. Inductive effect. What is inductive effect? If you want to learn about these all terms in detail, you should watch our previous videos. If you want to watch our previous video, you should subscribe this channel in order to get all the videos of this channel. Clear? So we are go ahead and what is inductive effect? So you can confirm the inductive effect from our previous videos, but now I want to that this is suppose CH3 CH2 NH2, clear, and this is NH2, clear, and this is NH2, clear. Okay, so the question is that which of the following is most strong base? Which of the following is most strongest base? Clear. So you know here electron are withdrawing toward this substituent here in the form of NH3, in the form of NH3 electron are inducted toward nitrogen, where here electron are also inducted toward this nitrogen. So the basicity of this chain will occur due to nitrogen because nitrogen have lone pair of electrons, clear. So you can see here the inductive effect of ethyl group is greater than these three hydrogen atoms. The inductive effect of these two carbon is more than these hydrogen atoms. So if a chain induct its electron to nitrogen atom, the electron density increases, charge density increases, reactivity increases, it means basicity increases, clear. Okay, देखिए here every atom have 12 electrons, 6 electrons, while here one electrons owner. So it means electron induction are greater here as compared to these three hydrogen. So the electron are inducted toward nitrogen atom, it means its basicity increases. While here you can see these three hydrogen also induct its electron, but their induction is less than this ethyl group. It means this one is most basic. Second number, this one is basic. This one is third because the electron is not inducted toward the nitrogen atom, but they have been withdrawn toward this ring, clear. So if the induction of electron increases toward the lone pair owners species, lone pair owners atom, their basicity will be increases because their charge density increases, their reactivity increases, clear. Okay, the next one is position of electronegative atom, position of electronegative atom, clear. Here we are only explain our summary of the chapter. If you want to study this chapter in detail, you can watch our previous videos, clear. So for example, this is an acid, this is an acid, clear, OH, clear. This is an acid, Cl is present here, clear. Position of electronegative atom, clear. And this is also an acid, this is an also an acid, clear. So you can see here, these all are hydrogens, these all are hydrogens. So in this case the electronegative atom is nearer than in this case. So if the electronegative atom is nearer to this functional group, the electron density will be attractive toward this negative electronegative atom. But here the electronegative atom is farther as compared to that, it means it cannot influence this OH as compared to that, clear. So if the electronegative atom is nearer, if the electronegative atom is near the functional group which have OH or which have hydrogen. Clear? If electronegative atom is near to functional group having H, so this electronegative atom will attract electron from this hydrogen, and as a result here the chance of bond breaking will be increases, because here the charge density decreases because electron are attracted toward here. If charge density decreases, reactivity of this negative charge decreases. It means its reactivity decreases and its stability increases, because it does not react with any other species, because its electrons are attracted toward this atom. It means the influence of electron withdrawing effect here is greater than this one, so it cannot withdraw electron as compared to that. It means this one is acidic, the upper one is acidic than the lower one. Clear? Okay. Because if we remove this hydrogen from this then in such situation this is stable conjugate base as compared to that, because this electronegative atom are near to this negative charge which attract the electron from this negative charge and decrease the charge density here, while in such situation the electronegative atom is farther, so it cannot attract the electron from this negative charge as compared to that, so electron density are higher here as compared to that. If electron density increases, its reactivity increases. If its reactivity increases, it will recombine with hydrogen H plus and form such type of acid again. Clear? So the next one, electronic configuration. Electronic configuration, clear, also affect the electronic configuration also affect the acidity and basicity of the atom. Clear? The you can see here that for example this is electronic configuration, these two are electronic configuration for two different species. Clear? So one is, suppose I write is for D, I want to write it for D. This one is for example D8, clear, and this one is D10, clear. This one is D8 or D10S1, clear, and this is D10. So you can see here in these two configuration, then these two species will attract electron. So which one of the following will attract electron more? So our guess will that this species will attract electron more as compared to that, because this species have unpaired electron. If it get an extra electron, it will become stable. When in such situation it is an empty, and an empty orbital is also stable, so if it gain another electron, its stability increases. It means electronic configuration also affect the acidity. So a species having such type of electronic configuration will have affinity for electron, love for electron, so such species will be acidic as compared to that. Clear? So I hope that you will be understood about all these terms. I have also uploaded such type of lectures about the strength of acid is base. So if you want to watch such type of videos and get benefits of such terms, you can subscribe this channel, and also if you subscribe the channel and click on bell icon, then you will get all such type of videos of this channel. So now watch again and again and write such type of examples clear, and very soon you will be able to differentiate between strong acid and weak acid, strong base and weak base. So okay.